Hi guys, let's talk about finding a solution to a system of equations through graphing. So a system of equations is when you have two or more equations. So in this case, we have one, two. So we have two or more equations and they have the same variable. So they both have x and y. So that's a system of equations. A solution is when we find where those lines intersect. So we want to see, we're going to graph these lines and see where they intersect. So I'm going to start with the top line. And the first thing we want to do is we want to find the y-intercept. Okay? The y-intercept is always my lonely guy or the number that's not attached to the x when y is by itself. So in this case, my y-intercept is -5. So I'm going to find that on the y-axis. Remember, the y-axis goes up and down and the x-axis goes across. So I'm going to plot the -5 on the y-axis because it's my y-intercept. Okay? My second step is to identify the slope. And that's always the number that's with the x when y is by itself, when it's in slope-intercept form, which means the y has to be by itself. And you'll notice on both of these, the y is by itself. So we can easily identify the y-intercept. The y-intercept is when it's the number that's not with the variable, and the slope is always going to be the number that's in front of the variable. Okay, so in this case, the slope is 1 because when there's no number in front of the x, it's always 1. Sorry, I'm being very messy today. So in this case, my slope is -1. And so my next step is to turn that into rise over run. Okay, and all whole numbers are going to go over the number 1. So this is going to be my rise, and this is going to be my run. So from this point, my y-intercept point, so I'm starting over here at this -5, and from there, I'm going to go down 1 and to the right 1, down 1 and to the right 1. And I can follow that pattern back in the opposite direction all the way across the table. Now I'll make my line, and it looks like this. Okay, so after I determine the rise and the run from the y-intercept, you follow the rise and the run. Whoops. I am being messy today. To make more points, okay? And then you just connect them. That's how we would do that. So let's follow that with the second one. So the second one, y equals 3x plus 1, we're going to find the y-intercept. The y-intercept, remember, is the number that's not with the x when it's in slope-intercept form. That's +1. And I'm going to plot that on the y-axis. So +1 on the y-axis is going to go over here. And then I have to come back and I have to identify my slope. And the slope is the number that's with the x. Okay, that's being multiplied by the x. In this case, it's +3. So I'm going to take that 3 and I'm going to turn it into a fraction. Whole numbers always go over 1. If you have a fraction, you just leave it as is, and the top number would be your rise and the bottom number would be your run. So in this case, my rise is going to be 3 and my run is 1. So from the y-intercept, now I'm over here. From the y-intercept, I'm going to follow the rise and the run. So I'm going to come over to my y-intercept, and I'm going to rise 3, 1, 2, 3, run 1. 1, 2, 3, run 1. And again, I can follow the pattern back the opposite way. It looks like this. And the intersection point would be right here. Okay. That's how we would graph, and we would use the coordinate pair. Now I'm going to give you a different one so we can just take a look if we're graphing in standard form. Okay, so let's graph in standard form and see how it would look. So graphing in standard form, that y isn't by itself. It's when the x and the y are both on the same side of the equal sign. So for instance, let's see. For instance, I have -5x plus y equals 0. And then the other one that I'm going to do is Okay, so these are the two lines that I'm going to do. Okay, and I'm going to start again. I'm going to start on the bottom line because it's in slope-intercept form. So I'm starting on the y equals 2x plus 3. I can easily identify the y-intercept because it's my lonely guy. So I'm going to plot that on the graph at positive 3. Next step is to identify the slope. And the slope is the number that's with the x. So my slope is 2. And I'm going to turn that into a fraction so that I can find out the rise and the run. And then from this point, my y-intercept, I'm going to move using the rise and the run. So I'm going to rise 2, run 1, make my next point. Rise 2, run 1, make my next point. And again, I can follow that pattern through the table. Okay, so this is y equals 2x plus 3. So I'm going to erase this here so we can work on the other one. So my other one now looks like this. I'll do this one in red. Now, a couple of things here. We can solve using the standard form, and that means that I'm going to find my x and y intercepts. So my x and y intercepts are when the other number is 0. So my y-intercept is when x is 0. And when x is 0, this would cancel out, and I'd just be left with y equals 0. So that is my y-intercept. Now, whoops, I want it in red. I'm going to plot that right here. Okay? Now, my x-intercept is when y is 0. So when y is 0, I would do this, and I would divide both sides by -5. And when I do that, oops, let me do a color. I'm still going to get my x-intercept is also 0. So I haven't gotten too far because that one point is both of the intercepts. Okay? What I can do is I could solve for y. If I don't get two different intercepts, I can solve for y. And in order to solve for y, I have to get it alone, which means I have to move the minus 5x. So if I want to move that to the other side, I'm going to add 5x on both sides. And you'll notice I have y equals, and 0 plus 5x is just 5x. And now it's in slope-intercept form. Okay? There is no lonely guy or no number by itself. That's because it's 0, and we've already plotted that point. Now we can easily identify the slope, which is 5. And I'm going to turn that into a fraction and do rise over run. And from here, I'm going to rise 5, 1, 2, 3, 4, 5, and run 1. And you'll see it falls on that very same point. That's where the two lines intersect, right here. So the coordinate pair would be 1, 5. That would be the solution to the system. It's where the two lines intersect. Now, I just want to show you one more thing. You may have something that looks like this. You may have y equals 2x plus 1. And then y equals 2x minus 4. Okay, so I'm going to graph the first one. The y-intercept, again, is my lonely guy, or the number that's by itself, which is 1. And then my slope, actually, let's change the slopes for a minute, because we haven't done any slopes that are fractions. So let's change these to 1/2. Okay, so now my slope is 1/2. So I'm gonna write that out, and this is my rise, and this is my run. I don't need to put anything over 1 because it's already in fraction form. So I'm going to rise 1 and run 2 to make the next point. And I'm going to do that. And there's my line. Okay, that's my first line. And now I'm going to look at the red line, y equals 1/2 x minus 4. Again, the y-intercept is my lonely guy, or the guy that's by himself. And I'm going to put that down here at -4, because this is the y-axis. And then I'm going to identify the slope, which is being multiplied by the y. So again, my slope is 1/2. And I'm going to do rise over run. And I'm going to rise 1, run 2, rise 1, run 2. And I'm going to follow that pattern across. I can follow it back. And you'll notice when I graph the line that they're parallel lines. And when you have parallel lines, they will never intersect. And if they never intersect, there is no solution. And that's how you would solve a system of equations by using graphing.